In this video, we will discuss the logic that was used when writing a greedy algorithm in order to solve a traveling salesman problem. A greedy algorithm does not guarantee a global optimal, however, it does guarantee that the local optimal is being chosen at every point. This being said, the global optimal is most likely to be chosen when the coordinates are more evenly distributed amongst an established region.
For example, if we are starting from Poughkeepsie, New York, the obvious nearest point is Madison, Connecticut. Though this is the closest point, it is apparent that this may not be the most globally optimal choice. However, if we were to start in the same location and travel to Syracuse, then all the way back around, we would likely be traveling in the most globally optimal route. In the following case, the greedy algorithm is likely to choose the most globally optimal route. The route begins in Miami, then to its nearest coordinate, Lynchburg, Virginia. Then the truck proceeds to New York, Michigan, Idaho, California, and then back to Miami.
In the genetic algorithm, the optimal route is found by mutating each chromosome based on a variety of conditions. After the best of each set has been determined, new solutions are determined using flip, swap, slide, and modification of the breaks concurrently with each of these techniques. The route distances are continuously being determined in order to depict which route is the most optimal from the randomly generated population. The greedy algorithm uses two for loops to communicate that the algorithm should choose the closest point that has not yet been visited. This is done by creating two zero matrices, one to keep track of the cities that have previously been visited and the other to keep track of the order of the cities that have been chosen. The minimum distance from the cities that have not been chosen is then found, and that point is set equal to 1 in the visited matrix. The loop is continued until each point in the visited matrix is set equal to 1. As you can see, the greedy algorithm took 3.72 seconds to find the optimal route, which the distance is 68.29. It is noted that the best solution history plot in the bottom right does not have a visible curve due to the fact that not as many iterations are needed to find an optimal solution. This is one of the reasons that the elapsed time is far less than that of the genetic algorithm.
As you can see, when the coordinates are kept constant, each algorithm outputs a route that is very similar to the other. This being said, the genetic algorithm found its most optimal route on the 1994th iteration, while the greedy found its optimal almost immediately.
We performed a statistical analysis by running each algorithm 10 times with 1,000 iterations for each run. The first time the genetic and greedy were run, RNG10 was used to ensure that the points would be the same for each model so that they could be correctly compared to each other. For each run after, the value in the RNG operator was increased by an increment of 5. The total distance and runtime were collected and the averages and standard deviations were calculated for both. The line graph displays the total distances for each solution of the genetic algorithm represented by the blue line and the greedy algorithm represented by the orange line. As you can see, the greedy algorithm always generates a solution that is a little higher than the genetic algorithm, but the standard deviations are very small.
In conclusion, the greedy algorithm has a runtime of on average 9 seconds faster than the genetic algorithm and has an average distance of only 7 units greater than that of the genetic. It is apparent that the benefits of the greedy algorithm balance out the slight negatives, making it a comparable alternative to the genetic.